Alright, then we skip number 22 and go to number 23. A skier is at the top of a slope shown in the illustration below. And that's basically the same thing I was talking earlier. You get the slope. At this point A, the skier is 10 meters above B. So you've got A and you've got B. A. Set the zero level for the potential energy at B. Find the gravitational potential energy of the skier. Well, you're just going to go MGH with the 55 kilograms and 10 meters for height. It says find the difference in potential energy between the points. Well, they're saying when the skier's at the top and then when the skier's at the bottom. When the skier's at the bottom, it has zero energy. Therefore, whatever your answer is the difference in energy. And then it wants to say B, repeat the problem where 0 is A. And so now instead of saying that you have a positive 10 height, you now have a 0 height, and you go down the hill and have a negative 10 height. And what's the change in energy is what it really is asking you here. And whatever your answer is for A is also your answer for B. Oh wait a minute, am I misreading that problem? I am misreading that. You have 0 potential energy when the 0 level's at A. Part C, repeat the problem when the 0 level's midway between. Now it's when the 0 level's here instead. So you've got, half the height above, half the height beneath, and it adds up. Guys, the whole idea of this problem is MGH, and then you can have negative height. Okay, you can have a negative height. It's entirely possible. If B is your 0 point, you're going to have all positive potential energy. If A, or the midpoint, is your 0, you can have some negative potential energy if you are beneath those points. That's the big deal with this question. Number 24. A 2 kilogram ball is hanging from a string, a distance from the ceiling. Let's see, 2 kilogram ball. It is hanging 1 meter below the ceiling in a 3 meter room. What's the gravitational potential energy associated with this here ball? So again, this is an entirely a perspective question. There's the ball, there's the ceiling. They're saying this is 1 meter and this is total 3 meters. And they're saying part A, if 0, or what is the potential energy of the ball compared to the ceiling? The ball is down 1 meter, MGH, where 1 meter is your height. Part B, what is the potential energy of the ball when the floor is 0? Well, now you are 2 meters above the floor, so MGH with 2 meters is your height. And then a point equal with the ball. Well, it's equal with the ball, it has no height, it has no potential energy. That's that problem. And last for this recording is number 25. A spring has a force constant of 500 newtons per meter. That's K. Show that the potential energy stored in the spring is 0.4 joules when the spring is stretched 4 centimeters and 0.225 joules when the spring is compressed 3 centimeters and 0 when it's unstretched. They're not asking you what the answer is. They're telling you the answer. All they want you to do is show that calculation. They give you the X, they give you the K, they give you the potential energy. Show that this number does equal that number. Show that you know how to do the calculation. That's it. The one thing you have to pay attention to is that the two distances given in this problem are in centimeters, and we always work in meters.